If you use standard AI image generators for client work, you run into the same wall every time. The outputs start to look identical. You get monotonous, cliched imagery that completely misses your client's specific visual identity, a problem the industry calls AI slop. By the end of this tutorial, we will build a scalable agency pipeline that solves this. You will have a system capable of generating hundreds of customized 2K resolution brand assets, with each image rendering in under 2 seconds. To set this up, you need the right hardware. Specifically, the foundational training phase requires a graphics card with at least 24 gigabytes of VRAM, or an equivalent cloud compute node. Once this pipeline is active, you stop relying on unpredictable trial and error prompting. Instead, you have a system that replicates your brand constraints every time you hit generate. Step 1 is initializing your environment. Download both the Krea 2 RAW and Krea 2 Turbo open-weight files. We need both because they serve entirely different functions in the workflow. This diagram shows the core engine behind both files, Krea 2's single-stream architecture. Unlike older models that process text and image tokens separately, here the prompt and the pixel data merge directly into a single unified processing pathway from the start. Bypassing the traditional multi-stream bottleneck drastically reduces the computational load. This structural choice accelerates the data through the network, increasing both inference speed and how accurately the model adheres to your text prompts. This graphic breaks down how we use the 2 checkpoints. On the left is RAW, a heavy 52-step model with a completely neutral latent space, making it a blank canvas for training. On the right is Turbo, a distilled 8-step engine designed strictly for high-speed production. By physically separating the training environment from the generation environment, you never have to compromise. You get the high aesthetic fidelity of a heavy model during setup and the rapid execution of a lightweight model during production. Let's start the training phase. Open your training interface, select the Krea 2 RAW checkpoint, and load in 15 to 20 highly curated reference images of your client's specific aesthetic. The RAW model excels here because it was trained under a strict zero synthetic data policy. It contains no AI-generated artifacts or predefined corporate guardrails, so it absorbs your client's exact visual style without fighting against a baked-in house look. However, you must not use the RAW model to generate your final out-of-the-box production imagery. Because RAW requires 52 heavy inference steps and skips all post-training aesthetic distillation, any direct generations you pull from it will look structurally weak and unpredictable. Looking at the training interface, once the progress bar hits 100%, the system successfully exports a local safe-tensors file containing your custom low-rank adaptation, or LoRa. This process converts those specific aesthetic patterns into a portable safe-tensors file that you can apply to any future generation. Now we move to production. Switch your operating environment entirely over to the Krea 2 Turbo model and mount the new brand LoRa you just created. Configure the Turbo engine with its specific operational parameters. Set the generation cycle to exactly 8 inference steps and drop your guidance scale down to 0. When you run those settings, the Turbo model delivers a near-instantaneous real-time rendering of a 2K resolution asset matching your client's style. At this speed, manual prompt engineering becomes your biggest bottleneck. You actually want to avoid writing complex paragraph-long inputs that might conflict with the system's native architecture. Instead, use the native LLang prompt expander shown here. You feed it a simple 5-word creative brief, and it automatically translates it into a robust sequence filled with specific technical, camera, and lighting terminology. Utilizing the expander forces the model to explore its full aesthetic diversity, which prevents your batches from looking repetitive. Meanwhile, your underlying LoRa continues to enforce strict brand safety. To see how this scales for an agency, we can run a stress test. We will freeze that complex, expanded text prompt in place and prepare to swap out the active brand constraints. Mechanically, all you have to do is unmount your Client A LoRa file from the Turbo engine and instantly replace it with a completely different Client B LoRa. Look at this split-screen comparison. Because we kept the prompt identical, the core structural composition remains exactly the same, but the color palette and artistic language completely transformed to match the second client. This modular architectural swapping is the exact mechanism that enables a digital agency to orchestrate multiple simultaneous client campaigns without bottlenecking production. Check your designated output destination. It is now populated with massive batches of highly consistent, client-ready digital assets. This represents a drastic reduction in manual labor. You have generated an entire campaign's worth of visual collateral in the time it traditionally takes to refine a single text prompt. Isolating your brand training on the unconstrained raw model allows the turbo engine to execute mass production at peak speed without losing stylistic accuracy. Before setting this up, check the provided documentation links to download the necessary open weights and review the specific conditions of the community license. Mastering this dual model pipeline moves you beyond basic prompting and gives you the ability to build custom, high-speed production systems for any client.